Hello and welcome to this quick clip having a look at addition polymers and specifically their environmental impacts. So addition polymers are used to make many plastic items that have lots and lots of different applications. They have very good engineering properties, so they're strong, they can be molded easily and made into different shapes for various types of items like bottles, etc. And they can also be used for many types of coatings, sealants and glues. So the way that these compounds are made, they start with an alkene, and many alkene molecules join together in a straight line to make a long chain polymer. And the unit that repeats itself over and over again is called the repeat unit. N is usually a number that's several thousand in magnitude. So let's have a look at some examples first of all. So let's take some ethene molecules, and if you expose them to free radicals, what will happen is that will help to break open the double bond so that the monomer molecules join together into a long chain. And this can happen almost indefinitely, so you have to decide when it's going to stop. So we do this by using a radical at one end and then get another radical at another end, and what will happen is a covalent bond will form, and then that will stop the chain reaction. So one example might be polyethene. Carrier bags are made of this that you can get in the shop. Polyphenolethane is used for protective packaging. But there's some problems with these seemingly amazing compounds as well. What happens when you want to get rid of them? So one option is to just throw them away. They end up in landfill. And because the properties that make them so useful to start with also makes them non-biodegradable. So they stay in landfill and don't break down, and they fill up the landfill site quite quickly. So that's one problem. Another problem is if we burn them. Sometimes people say that they're a good idea to burn them instead of digging oil out of the ground and turning it into petrol or gas, for example. But the problem is burning these can sometimes release toxic byproducts. So if we look at some common examples, you can see the trade name on the left-hand side, the monomer and the polymer that goes with it, and some of its uses. Now the problem is that you can get a range of different things off some of these. So polystyrene can release benzene, and that symbol there stands for long-term harmful effects, which in benzene's case means it's carcinogenic, it causes cancer. Hydrogen chloride is a corrosive gas that comes off when you burn black bin liners. So polyvinyl chloride is not a good one to burn. Teflon, which is used for non-stick surfaces, when that burns it releases HF, or hydrogen fluoride, which is even more corrosive. And one of the scariest ones of all is polyacrylonitrile, that releases hydrogen cyanide, which is highly toxic. So we can now see that burning them isn't a very good idea either. So ideally what you want to do is recycle them. Now, what we didn't talk about a moment ago is the carbon impact if they're burnt. So all of these various compounds contain carbon atoms, and the carbon atoms will burn in oxygen to make carbon dioxide, which is partially responsible for global warming. So it's really easy to calculate how much carbon dioxide is made from a plastic object. So you work out the structure of the original alkene from the stamp, the recycling stamp that you find on the bottom of the object. You then weigh your plastic object and you calculate the number of moles of your monomer that's present. From this, you can work out how many moles of carbon dioxide would be released if the object is burned, and convert that into a volume. So these are some of the examples of the polymers we've been talking about, and these are the symbols that come with them when you pick up an item made of each of these. So I'm going to take you through how we'd work this out for a plastic yogurt pot. So the recycling symbol stamped on the bottom of this pot is polypropene, which is obviously PP, and it's number 5. So in the recycling sorting center, what has to happen is all of the objects with 5 get bunched together in one container, all the objects with 6 go in another container, etc., etc. So let's start by having a look at what the monomer is. It's propene, C3H6, so you can clearly see that from 1, 2, 3 carbons, 1, 2, 3, 4, 5, 6 hydrogens. So the aim is to find out the volume of carbon dioxide released from just burning this yogurt pot. So the combustion equation is 1 mole of C3H6 makes 3 moles of CO2, because the number of carbon atoms in a propene molecule is 3, and then therefore that makes 3 carbon dioxide molecules. So this is the calculation stage. So we take the periodic table and we have a look at the relative atomic mass. And we use that to work out what's called the MR, or relative molecular mass. So there's 12 is for carbon, 3 of them makes 36, plus 6 makes 42, so it's 42 grams per mole. So the mass of your yogurt pot is 7.15, dividing that by 42 gives us 0.170 moles. Multiplying that by 3 gives us 0.510 moles of carbon dioxide. So therefore, multiplying that by 24 will give you 12.24 decimeters cubed. So let's put this in context. What's a decimeter cubed? It's the same as a litre. So if you imagine something like a 1 litre camping bottle, one yogurt pot will make 12.26 bottles of carbon dioxide. Quite amazing, really. Okay, thanks for listening. Until next time, see you soon.